and they're closing the doors, so I'd like to welcome everybody to the Khronos BOF with portable VR with Khronos OpenXR. So welcome to OpenXR. If you're not here for OpenXR, you're in the wrong place. If you are, this is the right place. So my name is Kay Mason. I'll just introduce myself quickly. I'm the API lead for Daydream and the specification editor for OpenXR. I will introduce the rest of the panelists in just a moment. So here's a quick outline of our session. We're going to discuss the problem we're trying to solve and the solution that we're proposing to take. We'll introduce the panelists. Each of us has prepared a couple of technical issues that we would like to discuss. We're going to have time for audience questions. We have a lightning round prepared if you all don't have enough questions. And we have some information about how to join the OpenXR initiative if you're interested. And we'll move on to tell you about the Khronos party tonight if you're interested in attending. So here's the basic problem statement. And the basic problem we have really is fragmentation of the VR ecosystem. So right now, I have my Daydream API, and Gear VR has their API. And these APIs all look somewhat similar in terms of the functionality that they're trying to do. But right now, if you look at what's happening, is that there's this huge matrix of engines having to write against all of our different APIs, which can be quite different. And we'll talk about some of those differences in the technical section. And device manufacturers are also having to write against all of these different APIs very differently. And that's creating, as we get more platforms and as our platforms diverge and do things differently, it's becoming even more complicated and the lattice becomes worse. So our solution to that is to insert this OpenXR framework in two levels, at a device layer, which is basically below the runtimes, and at the application interface layer above the runtimes. So applications can write against the OpenXR interface, which would be able to be used on any of our platforms, and devices could write against the device layer, and would be able to use a similar interface on any platform that supported it. So here again is the layered architecture. It's very similar to the last diagram. So we have, again, two levels of API interfaces, one at the application interface layer and one at the device interface layer. So if you wanted to make your own VR controller, you could write against the OpenXR device layer, and that would be supported on the platforms that support that layer. So this is a list of the participant companies who are participating in OpenXR. So you can see I'm from Google. We are participating. We have Oculus. We have ARM. Brad is here from ARM today. We have Tobii, who's an eye tracking company. They do amazing work. Samsung. All of these companies have come together because we all have a common goal of wanting to create a standard interface and leverage our common knowledge to make things better. So without that, I'll move on to panelist introductions. First, me. Again, I already said that I'm the API lead for Daydream, Google VR. I'm also the specification editor. My PhD is in computer science, focused on AI and non-photorealistic rendering from the University of Calgary. I'm Canadian. I spent 10 years at Electronic Arts as a video game programmer. My last game was Sims 4, and my first was Return of the King. At Google, I worked on Google Earth before I worked on the Cardboard launch, and after the Cardboard launch, I moved on to the Daydream team, or the team which became Daydream. And my basic goal is to make VR universally accessible and useful, because I like that motto. It's awesome. So I will move on to introduce Remy, and I'm going to go through people's bios, and then we're going to ask the panelists some introductory questions so we can get a feel for why they're here, what their contributions are going to be, and what they're looking to get out of VR and OpenXR. So Dr. Remy Arnaud serves as Chief Architect Officer at Starbreeze, leading developments such as Star VR SDK. He involved early on with real-time image generation in Paris, where he did his PhD. He then relocated to California and has since worked on many projects, including Silicon Graphics' Iris Performer, Keyhole's Earth Viewer, Go Earth, Intrinsic Graphics Alchemy, Sony's PS3 SDK, Intel's Larrabee game engine, ScreenPoint's 5D City. Well, I don't think I can pronounce it. Game engine, collaborated to various products groups, OpenGLEX, Collada, GLTF, WebGL, WebCL, and OpenXR. So Remy sitting there.
Hello.
And next to Remy is Brad Grantham. Brad Grantham currently specializes in workload analysis for GPU architecture in ARM Inc.'s media processing group. He's been an OpenGL developer since 1997 and has presented at SIGGRAPH and ARM TechCon. Brad previously worked on Iris Performer and the Fahrenheit Scene Graph at Silicon Graphics, benchmarking samples and applications engineering at ATI, now AMD, and driver design and implementation at ARM. He recently wasted a lot of personal time writing an Iris GL-compatible transformation and lighting library for a handheld retro computer. Doesn't it sound awesome, though? Dr. Nick Whiting is currently, who's sitting next to Brad, is currently overseeing the development of the award-winning Unreal Engine 4's virtual and augmented reality efforts, including shipping the recent Robo Recall, Bullet Train, Thief in the Shadows, Showdown, and Cough Nights VR titles. Couch Nights VR titles, sorry.
Kind of like Cough Nights,
Cough
though.
Nights,
That sounds pretty
that's fun,
sweet.
though. Previously, I'm not nervous or anything. Previously, he has helped ship titles in the blockbuster Gears of War series, including Gears of War 3 and Gears of War Judgment. You owe me a lot of time because that was awesome. Anyway, he is also currently serving as the chair of the Khronos OpenXR initiative, working to create a standard for VR and AR platforms and applications. Okay, those are our panelists, so let's get to the introductory questions. I'm going to ask them all, and I think we should start with Remy because I've been talking a lot. So Remy, what is your personal involvement in OpenXR? Why are you and your company involved? How will having the standard affect your work? And how do you think having the standard will affect the VR community?
Thank you.
Go ahead.
So I've been involved with Khronos for a long time now, as you mentioned, and it was natural for me to wanting to get involved and be at the table with every of the actors to create a standard API for virtual reality. And that was only natural for me to be involved in it. And also because I work for Starbreeze, and we are creating one of our product, and that's kind of crazy for a game company to do that actually, is to do our own hardware VR device. And our company decided that we wanted to provide the best possible entertainment to our community of game players. And for that, we went to the route of local-based entertainment, where we hope players will want to go out of their home into places where we install experiences that are not possible to run at home, and that includes the best high-end possible VR device, which is why we do Star VR. So in that aspect, I am responsible for the software at Starbreeze, and one piece of software we have to do is the software development kit for our VR device, the Star VR SDK. That means we create an API that our customers need to use the Star VR SDK. So yet another API. After the one from Oculus, from Valve, from Google, and so forth, we have to create our own because there are features that we need that are required for business. And so what really changed for me, it will change everything, because then I won't have to do my own API. I would just make sure that two things, make sure the specification that we're working on has what I need, and then after that, we'll make sure that what we program follows the specification and is following the standard. So that's going to change a lot, because it will basically change all the API that we currently have in our SDK.
Same questions, Brad.
Great. Thank you. So my background is OpenGL and GPUs, and so that's how I kind of come into this. I've always been a fan of Khronos, and so volunteered for the effort. And it's been working out pretty well for me. But I just represent, when I joined the working group, I represent all of ARM. And the reason we're involved is because we have all these products that we make, from the GPU to the CPU. You guys are familiar with ARMs and lots of phones. And we also make graphics chips and display chips and video and lots of other bits and pieces throughout the system. So it's in our corporate best interest to make sure that we have some visibility into the standard, and also can offer our requests for what needs to be in the implementation and the spec. So we're kind of at the bottom, and I don't want to speak for other people who have mobile parts, but but I will put that hat on. So I guess I will do that. And at the bottom level, chip manufacturers are all serving support requests and helping people integrate their IP and systems on chip into these headsets and whatever. And that's a little bit of a burden because of the fragmentation and all the different runtimes that need to be supported. So I think our hope is that as these things converge, that cost of implementation and integration will go down, and that's good for the industry. And then following on to the final questions, I think that the biggest benefit to the community is going to be the availability of content on more platforms, that the barrier will be lower. And I think of it in terms of being, well, you can speak English and you can speak French, but it's a little bit easier to speak American English and British English. So even if the runtimes are very close, there are bound to be subtle differences, but subtle differences are way better than completely different SDKs. So that's my basic thinking.
Thanks, Brad. Nick?
So my involvement with OpenXR kind of came from a very selfish place. Like Kay mentioned, I'm the director of VR and AR at Epic Games, so we make the Unreal Engine, which means a lot of people are using our technology, and we have to support a lot of different hardware platforms. And I've been doing this not as long as some of my esteemed colleagues have been doing, but for the past 5 or 6 years, I've been involved, and it's been a very organic effort initially at Epic. And so it was just me after hours doing SDK integrations for Oculus and then Steam VR and a few of the other ones. But it was kind of a one-man army sort of thing. And initially, all those integrations were very disparate. Everybody had kind of their own spin on doing things. But as the years went on and we approached kind of the first consumer releases that happened kind of last year and the year before that, we started to notice a lot of patterns, and there was a lot of that code that became redundant. And so from a completely selfish point of view, if we had an open standard that we could just code against, we could put all of our limited engineering efforts towards a single standard and make that as good as possible, and then work on what makes each platform unique and dedicate the engineering efforts to that. I think one of the people came up to me after we had started the OpenXR thing and with the question saying, hey, would you standardize a self-driving car right now? He's like, I think it's way too early to standardize VR and AR. And I'm like, well, I wouldn't necessarily standardize the self-driving portion of the car, but I know cars usually take 4 wheels or some number close to that, and they need a steering wheel, and they need a go fast button and a slow down button and stuff like that. And that kind of functionality is really what I want to standardize in OpenXR, so we don't have to keep reinventing the wheel, as it were, with it. So I think the other benefit to us as a middleware company is it's in our best interest that AR and VR are successful. And one of the biggest issues right now is the market is so small that people trying to enter the hardware market don't have a lot of content because most of the teams that are making the content are so small they can't support every device coming out. And conversely, the people that are selling the applications need to have as broad of an addressable market as possible. So my hope is that the VR community really benefits by this standard, because it will connect hardware people and application people to a much broader range of content, which will in turn kind of reinforce it and help grow the market and make it a viable business for some of the smaller people. And I really think that some of the most interesting work comes out of the smaller teams rather than the gargantuan teams. So that's my personal hope for VR and OpenXR.
Thanks, Nick. From my perspective, I feel like our team did a lot of things right when we wrote our Daydream API. Some things that we're really proud of are like our fast path video that we'll actually talk about today a bit. And some things that are smaller things that I would change. For example, I used matrices for determining head poses and quaternions for controllers, which I'm like, now, there were reasons we did it, but I'm like, oh. And bigger things, like there's no way to do extensions in the Daydream API, the current Daydream API, which I would really like to be able to extend my API a little bit more than I can currently. So how will it affect my work? Well, in the short term, I'm going to have to write a whole new API and implement it against Daydream, so that's going to be a little intense. But in the longer term, I'm going to be able to leverage what other people have learned. For example, we've already talked, if any of you are familiar with where Daydream is going now, we've announced that we're moving into the positional space. So we're going to be able to leverage knowledge that other people have in that area that we're newer to, at least so far as VR goes. And we're going to be able to work together and come up with ways to do that. And they're going to be able to leverage our knowledge as well, which is great for us. So And I think it's going to benefit the VR community too, because we'll be able to share each other's. And when we come up with hey, this isn't working because this API isn't working, we need to add something to it, we'll be able to discuss that, and we'll all be able to share instead of having to fix these issues independently multiple times. So now we'll move into our technical issues, and we'll start with Brad, who's going to talk about mobile XR.
Right, so maybe I'll ask a question first. How many people have used the Rift or like a tethered display or developed for that? This is pretty much almost everyone. How many have used a Gear VR or head-mounted display with a phone that inserts into it? Fair number. Okay, so you know basically the deal here. Smartphones are an enormous market and getting bigger. All of these mobile systems on chip, GPUs, the game revenue for these mobile platforms exceeded consoles and PCs last year, which puts even more pressure on content developers to ship for not just the tethered display, but also the mobile display. And so that's a key thing that any VR AR API would have to address. And that's one of the reasons that we're interested and want to be present. Another thing that is very key about these platforms is that they're very constrained. The amount of power that you can use is just sipping, like about a watt. And I've managed to miss a comma here between 1 watt and thermal throttling. But what I meant to say is, if you draw more power, which is available, typically that means more heat. And these devices aren't very well suited for heat dispersion, so they'll get hot and eventually clock themselves down in agreement with the system software and the system on chip. This is not a very good experience for developers of content. Suddenly your frame rate is stuttering and things aren't behaving the way you expected. So managing power use and managing your clock rates is critical, and a lot of the VR APIs have that feature already in them, but various interfaces and so forth. So one of the things that's important to me, and I'm trying to keep tabs on this, is developer tools and the API, the interface for measuring and managing both power and temperature, so that you can have a consistent frame rate and you can manage a really long lifetime for content to play back. So that's one of the features that I'm keeping an eye on.
Thanks, Brad. Moving on from there, Remy, do you want to talk about the opposite end of that spectrum?
Yeah, although we don't know where the devices are going, so I don't know, maybe we can use for phones and put them that way with some system and get a very large field of view. But it turns out that our aim is to be as close as possible as the perfect system, and that actually we do cover the field of view of the human being. So in that case, the 210 field of view by 130, it depends exactly on the exact numbers, but that is what we're aiming for, and that's what we have. And it's relatively bigger, as this image shows, than even the PC, not even the mobile one, but the PC HMD headsets. So the thing with that is it's highly, I'm not going to go into the math, but it's highly unlinear. The larger the field of view, the more the density of pixel is changes. And if you imagine a curve that's like a tangent curve, it's kind of linear up until like 45, and then it becomes totally in the 90-degree direction after that. So the problem is not linear. I mean, going from 90 to 120 is not just a little bit of a problem. It's a much harder problem because it's an exponential problem, actually, as far as managing the density of pixels. So we have developed solutions for that, and we have one API, and we have, we delivered multiple games with that, and our customers use that. But it's not fun that you have to rewrite to another API to be able to go to the high end. That's Silicon Graphics. We already had this thing where we wanted the same content to be able to, same application to be able to go and to scale up and scale to better hardware. And as a content developer, it's like, well, I have this application, it works, but I want to put more content, or my customer has a bigger model and I want to be able to, or they want a larger field of view for their experiment. So I want to be able to just do it without having to rewrite my application. And that is the case today, though. So it's kind of challenging, and we actually went through that at the working group, and it was really good discussion that we had. How do you make an API that can cover both ends of that spectrum and actually don't impose people to deal with high field of view if they don't need to, but at the same time enable people to do it if they want to. So I'm really looking forward to be able to have this API to enable more applications to go to the high end when that makes sense. Now it's not magic because when you create content, you have to. It actually has an impact on the content itself. Not only performance, of course. There's a lot more things you see, and so there's more performance and more pixels and so forth. But it also has an impact in the gameplay, for example. We are really sensitive as human beings to movement on the side, and not so much to colors and shape, but really to movement. So if you have things in your game that moves that way, it better be part of the gameplay. Otherwise, it's going to be really perturbating, really problematic for the player. Now, if you make a game for low field of view and things happen here, they're never going to see it unless they actually turn their head to look at it, which you need to provide some hints in the game for people to do that. So it's actually a very different gameplay or design when you design for large field of view and a small field of view. So you need the technology, you need API, but there's no magic button. You need to create your content based on what the experience will be.
I'm kind of curious because when we talked about this in the working group, there's a lot of discussion about what the best way to represent such a wide field of view is. Is it multiple linear projections? Is it some sort of alternative projection to order that? But it seems like one of the ways to solve that would be some degree of ray tracing or band tracing or something like that. Have you guys thought about that, or you guys like the multiple layered approach?
So there's many ways of rendering. There's a lot of rendering algorithms. A lot of those are talked at during SIGGRAPH. But the OpenXR API is not about how people render. It's about presenting. So you could include the presentation in your rendering, but then that becomes one thing. And yes, you could do with ray tracing an exact model of the screen. You could do it in one pass, but that's not exactly what we do here. Right? We're trying to have a way for developers to use their engine, their method ray tracing or not, and then have a way to separate from the presentation, which is what this API is doing. So, yeah, I don't know, maybe something like that in the future, but at the moment it's more about using existing engine and making sure we can go on the different VR devices.
I do want to say that there's a careful balance that has to be struck between flexibility and number of features and portability. And there's a danger, and the working group has experienced this, sitting down and just saying, well, what should be in there, what could be in there? And the statement of work is fairly clear about the scope of API for 1.0. And so that there's plenty of opportunity in the future for things like ray tracing and different kinds of projection techniques and different kinds of layers and compositing and so on. But the scope is pretty clear, and then there's still an opportunity for extensions. And so this is kind of a careful balance that all the Khronos APIs have to walk, where you want portability, but if you have more development budget and time and so forth, you can use extensions. If you want to innovate, if you want to target your content for sort of the larger base, and then you have special features you want to show on something like a Starbreeze, like a very wide platform, you can do that, and it lowers the barrier. That's the goal.
Yeah, it's much easier to kind of make a mode for large field of view than it is to write it from scratch, I think, in applications.
Yeah, it's going to be so much easier. But like I said, there's no magic button. Your content will have to be fitted for it. So, but at least you have only one language to learn, one API, and it's going to be much easier.
Maybe that should be the next Khronos effort, is the magic button, open magic button. It just does everything for you with a single API call.
So the next issue is color spaces. Nick, do you want to?
Yeah, one of the things that's kind of plagued us with our current generation integrations with Unreal is we make middleware, so we want to kind of sell the fact that people can develop the content once and deploy it anywhere they want. And we do a lot of engineering work under the hood that we're hoping to eliminate via the standard. But right now, one of the things that really gets to us is when we make content, the screens that are in the different HMD devices use different technology. They have different characteristics. They have different optics. They have different lenses. And that results in the very same content looking very different on here. So I kind of photoshopped an example, and I'm not sure how well it comes across on the projector. But if you run this very same content, which is some internal stuff that we made, on an Oculus Rift versus a Vive, there's a very, very different color response on the screen. On one headset, it looks very washed out. On the other one, it looks a little bit too dark and saturated. And that's because the gray levels and the darks are reproduced very differently on them. So one of the things that we really wanted to do was figure out how to standardize color spaces so that with OpenXR, we can support as wide a base of platforms, or as wide a base of devices as possible, but still have the same content work across the board. And this is one of the first things that we ran into. So we were talking in the group, and it's kind of a hard problem because there's a couple different standards. People at SIGGRAPH are probably familiar with the ACES color standard, which is a really complicated but very thorough standard that is used a lot in film. And it specifies a bunch of different transforms at a bunch of different levels, but basically it's all about getting to a standard color space and then defining an output transform for the device so that you can render it, and then the device will transform that content and display it consistently across there. But as we were talking within the working group, we're like, do we want, that would make us dependent on another standard, which is maybe not the best thing to do. It's also a hugely complex standard because it is so thorough and exact, because you have to use it for film. There's very high tolerances and performance isn't a thing. But with VR, when you have 11 milliseconds to render a frame, if you're lucky, we can't necessarily afford that. So one of the discussions we had was how can we rectify that within there. So I don't know if you guys have any comments on that in particular.
I can make a quick comment, which is I think often this is another case where we have a big difference between mobile and these bigger platforms because we're often dealing with 8 pixels per color channel, and that really limits what we can do and what kind of color space transforms we can do without getting visual artifacts in there. So for us, it would be very different. So I guess it's just another case where we have to, when we're writing the API, we have to take into account the fact that things are different on mobile. And much as we'd like them, and much as they might be different in the future, this is the reality that we have right now.
Yeah, a lot of people were wondering, do we even standardize this at all, or do we provide hints to the runtime necessarily? One thing we could do is say it was authored on this type of device, and it looks good on, say, a Daydream device, or it looks good on an Oculus Rift. But then the runtime can maybe take that information and say, oh, hey, that's a hint. I know that I need to, drop the grays on this or something like that to match it. The problem with that, though, is you kind of get this large end-by-end matrix of all these combinations, Oculus Rift to HTC Vive, Oculus Rift to Daydream, Oculus Rift to another Daydream phone, because even within the platforms, especially the mobile platforms, it's not consistent with what the screen is like. It's kind of an open question. I'd be curious if anybody in the audience has any thoughts in particular about that, because I don't think we still have a great solution for it, but it's one thing that we really need to consider. This is just kind of one facet of how do you make this work across a large swath of devices.
Well, there's a lot of things we do in the OpenXR API that are related to presentation, and that's one of them, right? Mm-hmm. Because there's the distortion, and there's the color deformation. Per each color, you may have actually a different distortion to apply. Mm-hmm. And we actually had, if I remember it correctly, on mobile it may not even be possible to do that. Mm-hmm. And then you have and then the color correction. So it looks like some of the device will have an approximation of the implementation. The quality will be lower because it's a cheaper device or a lower quality device. But as long as the API and information exists and the customer buys a device that matches with his quality requirements, then I hope we can see what it needs. The worst part would be the content is created for a low-end device and you buy the expensive device and you see the same thing. That would be the worst output of any decision we make here. Mm-hmm. We can't magically make a low-end device do high-end things, but hopefully we can make sure that the applications and content can scale.
Yeah.
Can you move to the microphone?
Is it one up there?
It's over there, sorry. But it won't be on the, okay, I'll repeat what you say.
Would it be out of the question to develop a sort of a test pattern? Let's think in terms of television, where you have the old test pattern with the color bars and the contrast bars and things like that. Maybe you could augment that with some other things, maybe with field of view or something like that. But let's address this here as a thought experiment. We have contrast and saturation issues. So we just have a standard that we view with an HMD, and then we adjust it to get to how we want it. We see what's viewed with HMD, we see what the standard is, and then we adjust it so that what we're viewing through the HMD looks exactly like the standard. So it has this much contrast offset, this much saturation offset, whatever these deltas are, and that becomes part of your device capability thing. When you render the content, you say, oh, what's my contrast offset, what's my saturation offset based on this standard measurement system. Make sense? Instead of the n-by-n matrix, because that's going to get crazy, especially as more devices come on. So it'll just be like property offsets of standard.
Yeah, that was one of the things that came up in there, and we were toying around, especially with the hardware members of the group, about if they had anything internally that was kind of like that. The one concern that a few of them did raise is that they have different requirements in different areas of the lens, because their lenses are typically nonlinear. So that test pattern, you need to do a test pattern in different quadrants. How many quadrants is sufficient? So that was one thing that had been brought up as a possible avenue to do that, and then trying to quantify the results of that data somehow. But that was one of the surprising learnings to me, I think, is how much of an art this is rather than an exact science with optics with these device manufacturers.
And you've got a, I think that's a good idea, and we did discuss the test pattern, but so that if you're a head mount manufacturer or, and you've got your device, and you want to be able to say this works really well, then now you have an issue of one unfortunate thing is if you have multiple runtimes, you're going to have to measure each one. Some of them may have different capabilities. Some of them may have special stuff baked into a shader that can change color spaces and things like that. So that's just one more concern. Like, what do you do in that case? And we've been discussing that. So.
Yeah, and the other thing we discussed is how do we get to the picture itself? And that means we can't really get to the picture programmatically. You have to look at it through the camera. There's no other way. And so then how do you design a camera that works like an eye and that the frequencies of the different devices may run at, which are going to be very, very different with, different field of view actually, which is a big deal for cameras, and looking at the pattern, which has to be a 3D model in our case. And
you're talking about like an automated test kind of thing?
Well, how do you judge, right?
Yeah, how do you do the final
If I
test?
look at it, I may have a biased judgment. So that's kind of a things that Khronos never actually set a foot into automatic computerized, image. I mean, we barely do image comparison for things like OpenGL rendering, where we try to make it so it kind of passes the test. Those are really complicated, depending on if you have anti-aliasing or not. I mean, it's just like super complicated to do anything that is really reliable as far as the result of the testing. So.
Okay, moving on to the next topic. It's about performance levels. So I put up two examples here. I think the text will probably be too small, but this is an example from the Android API for sustained performance, and also from the Oculus or UVR API with power management. So this is something that we both have to do, and I suspect all devices really have to do it because our phones get hot as we're using them. And as Brad mentioned, that really makes a big difference because, as you know, when the conductor gets hot, it doesn't conduct as well. So the hotter your phone gets, the more power it needs to draw to do the same things, so the hotter it gets. So as your phone gets hotter, it's more likely to get hotter. So you really have to, as an application, manage your power consumption. And we've provided APIs. Android provides the Sustained Performance API, and Oculus provides the Power Notification and Management API that you can use as an application developer to tell, okay, my application is heating up the phone too much. If I continue down this path, I'm going to overheat the phone very quickly, so I need to scale back. Maybe I need to make my textures a little bit smaller. Maybe I need to render fewer layers. Maybe I just, as an application, you know best how to downsample your application or how to make it consume less power and optimize it. So how we do this now is quite an interesting question, because if I provide you with, right now we have, so Android will provide a sustained performance mode, but what that means is really up to the device manufacturer. So if we're creating a sustained performance mode on a device that's manufactured by some hardware manufacturer, it's up to them to tell us what their hardware is capable of running at, like how can this hardware run slower. So we need information from them, and then the next version of their device, maybe it has a different hardware requirement. So how do we write an API that will allow future expansion? Because maybe something that's super hot right now, next year it will be totally fine to run at that temperature. So how do we do that in an extensible way? And I think that's a really interesting problem, is one we've been discussing, and it's one that we've had to tackle as Daydream, and one that Oculus has had to tackle as well. So where that goes, I'm kind of excited to see. So.
Yeah, I think we all seen what happened if we don't have that. Have you seen one of the episodes of HBO Silicon Valley where everybody has the phone and they look in VR and every phone explodes in the audience? Have you seen that?
No.
That's what happens if we don't control the temperature.
Great. Anyone?
I think we have a pretty, I would venture to state we have a pretty good technical understanding of what it means to set the clock rates and measure temperature, and most devices have that capability, but what I'm discovering as I listen to people talk about their content is most people, if you tell them they can set the clock rate, it's not clear that that they have enough information like to do the right thing on every device. So there's this very large question of, you have a very broad base of all these devices, like Kay's saying, and what do you do to make sure that they can all operate the way your VR app expects? It's kind of a very big open question, and I've been surprised to find out all the different ways people look at how they could do performance management and have this sustained mode. One thing that people like to ask is, can I just turn up the clocks and run flat out as long as I ask you to, which is going to be very short, and then the question is, how short is that? Is it going to be like milliseconds, part of each frame? Do you want it to do for a minute, 2 minutes? What happens if it gets too hot? And you said you needed sustained, like very high performance mode, and it gets too hot. What do you want us to do? So there's a lot of, all the existing SDK vendors have really well-established positions, and so there's a lot of that filtering in.
Yeah, I think it's also kind of an interesting application developer side question as well, because we found that a lot of people are experimenting in VR and they aren't necessarily completely familiar with real-time development, especially on mobile platforms where heat and battery are a large concern. And so they're like, oh, performance mode, that makes everything go slower. I'm going to uncheck that box. And then they're like, why is my app running at a terrible frame rate? It's like, well, your phone's trying to keep it from self-immolating. So everything got clocked down. So I think in addition to being an interesting kind of technical question, it's also an interesting question to say, how do we surface this and how do we enforce it? Or do we enforce it at a standards level? To prevent people from hanging themselves in these sorts of applications. I'm kind of curious to hear your perspective on that, since all I hear is users complaining it doesn't go fast after a second because they've burnt themselves out.
So it's not completely related to that. There's the temperature also affects the screen itself. So the different temperature, the screen is going to have different the colorimetry changes with the temperature of the screen. And on the ion field, HMD, actually, we have a fan in the headset itself, which doesn't do the calculation. Calculation is on the PC, which has its own fans, but we do have a fan in the to control the temperature of the screen to make sure it's always the same colorimetry and the same display all the time.
Okay. Next item, location-based entertainment. Remy?
Oh, yes, so like I said, our main purpose in life is entertaining, and as a company, me too, maybe. And so we have a few games. Actually, if you have the chance, you can check out IMAX VR. It looks like a movie theater, but it only contains VR entertainment. It's in Beverly Hills, which is 20 minutes away from here. We have two experiences in there. One is called John Wick, and the other one is called The Mummy, and they are made with the movie studio as an extension of the movie, or as a, hey, if I was kind of be in the scene myself, and it's really, really good. But for that, we creating experiences that are bigger and better, and our CEO has dreams of having a lot of people playing a game simultaneously in a large room scale with tons of objects that are virtual and real and participating in the game. This means we need to have a very large, tracking system, very large. You know, I'm here about the room scale tracking system, where it's about 5 meter diameter. We have tracking. If you can see the guy at the end and the thing on top of him, that's a 5 meter. And the tracking system we use is, you know, way larger than that. That's give you the scale. So it's very important, once again, that the API, as far as the tracking devices, can scale. And we can have, you know, on this very large scale and input. And the other thing is we use a lot of different controllers, which actually look like this thing, which looks like more a gun. It actually is the real gun that you can actually has the real weight and has exactly the 3D model is the model of the gun, right? So and we track it, and we track tons of other objects that you play with which have the real feel because they are the real objects. So it's completely different than using a mouse or just a standard controller to you know to shoot with or to you know, do things with or grab things with, and using some kind of universal controller. We create a different controller for every single situation. Also, benches that move, and I mean robots that play with you as non-playing characters in VR. Non-playing characters are actually things that move in the scene. They exist physically, so you can bump into them and so forth. So. How do I make an API that can enable me to take all those different things and to be exist as devices and the application can access to it? And it's not that complicated, but it's just something that needs to be thought about in the API, so it's possible for VR to be what we think it should be. You know, not only just pointing and clicking on things, but actually having a full experience that looks like reality.
I think that's one of the things that standardizing can really help is abstracting that away from the application developer, because one of the biggest things that we get for location-based stuff is people want to add a Vicon system and use an Oculus headset or something like that. And if that can all be abstracted away from me and I don't have to deal with it, I am all for it.
I'm going to skip a little faster because our time is so. I put a slide about mobile video in here, but again, we talked a little bit about differences between mobile and desktop systems, and video is one of them. In the case of this is kind of from the Android open source project documentation. So when we decrypt video in Android, in order to keep it secure, we're decrypting it to what's called a surface texture pair, which is an Android class, and we can only decrypt video to a surface texture pair in Android. That's the only option to keep it secure. And you can see in this model, it lives in trusted memory. It doesn't live in the application's memory, which means in order to composite that video in, we have to do some kind of magic. We have basically a couple of options. One is we either have to, in our compositor, in the trusted layer, copy the video from the surface texture pair, which is a wasteful copy, or we have to make a way to pass that Java construct down into our little code, pass it to surface player directly, which is an Android class that deals with these things. And so in Android, we basically need a special API to pass these video constructs, the surface texture pair down. And that's something we need in an API that the desktop doesn't need. So that was all that was there for. Comments, or should I move to the next one?
Well, video is a big part of VR, so we've got to do something about it.
Future proofing.
Yeah, so one of the things that we were concerned with is kind of future-proofing, because if a standard is obsolete the time it releases, it's not really going to get any adoption, right, because it's kind of useless. And Joe Ludwig from Valve actually put it really well. He's like, hardware device manufacturers tend to stay around, but dev teams are ephemeral. And what he means by that is, you know, in a year or two time, it's much more likely that a dev team will have disbanded or they can't recompile their game if they need to update the SDK or something. So one of the things that we really wanted to think about from the get-go was how do we future-proof against devices? Because if, you know, the last 5 or 6 years have taught us nothing, it's that things are going to change, and pretty soon we're going to have wide-field chicken VR, as in the picture there. So there's a lot of different approaches to this, but I think one of the things that's difficult about it is if you make the API a little bit too general, it's not useful for anybody, right? You can't get optimizations, you can't get the performance that you need, and you end up hanging yourself in that way. So one of the things that we've been concentrating on is how do we make this API extensible within reason? How do we handle new classes of controllers? How do we handle if we need to pass extra data to the compositor if a new technique comes down the pipe? So it's one thing that we've been kind of wrestling with, and I think we're ending up in a good spot right about now. I'd love to talk about more technical details, but I can't. But I was curious if you guys had any thoughts on future-proofing devices, especially I think it's particularly hard with mobile phones as well because the capabilities tend to change so much between generations.
I think it's connected to the notion of scalability, right, as well. It's like how can we scale from, how make sure that there's no, I mean, there's no blocking that we built in the API to limit the devices that already exist in a big scale and may even be larger in the future. So I mean, it's very hard to do something like that, but by trying to not have artificial fixed values in there that will be a problem pretty soon, then we should, we just need to be careful about that.
Yeah.
This is kind of one of the basic reasons for having the working group at all, is to have enough people who have their interests be there to say, well, we have a thing which is going to be 210 degrees and we need that represented. And everyone can say, okay, great, we'll take care of that. We'll make sure that can at least, that's at least not forbidden. So it's kind of an opportunity for anybody who has a crazy thing that they think is going to be really great to show up, within the membership of Khronos and say, this is important that I represent this. And that's, we actually have pretty good representation, I think, across the industry of people saying, well, we can't necessarily tell you what we're building in 2 or 3 years, but this example feature that you're discussing would forbid us from making that, so that's a problem. So let's talk about what the solutions could be. There's a lot of that going back and forth.
Yeah, a standard API has way more chances to reach that, to address that problem than an API made by one company for one product, right, for sure.
Yeah, and I think, your example of location-based entertainment where you have a wide variety of controllers all the time, how do we kind of future-proof content so that if you're using a gun versus using 2 motion controllers, you can still use the same application?
Okay, moving on. Compositing layers, Brad.
See if I can go through this a little bit quicker because we're running shorter on time, right? So the reason that I threw this slide in there is just calling back to my interest, which is mostly GPU bits. So one of the last things that happens in the pipeline, well, it sounds like a small thing, this reprojection and correction to take care of chromatic aberration and lenses and warping the image to where your eye is going to be looking. That's a pretty big deal, and it's actually a fairly heavy workload for GPUs because of the shader math. And it's got system implications all up and down, video and display and the CPU as well. So part of the effort that I wanted to call out was just this working on the balance between setting a baseline for performance and feature levels, but also allowing innovation with extensions, and that's always a careful negotiation between people. I wanted to try and set up for the next slide with that.
Okay, this is frame scheduling and blocking. So now that we've discussed compositing a bit and compositing layers, one of the issues that we have with our APIs, or at least with us and with Gear VR, Oculus, and Valve's APIs, are the fact that we all block in different parts of the frame, which makes Nick want to jump out the top floor of his building sometimes.
This is the one problem I would love to see solved by this group, if nothing else.
There's good reasons why we block when we block. So we're all trying to minimize latency in the best way possible. And for us on Daydream, we manage our own swap chains, so internally. So we block when you acquire a buffer to draw to. So we give you the buffer as soon as it's ready, so you can start your drawing. That's our arm. And we have applications that are doing some rendering outside of, that's not even for the frame. So for example, an application like Google Earth may be pulling down data off the web to render some frame in the future. And it's trying to render that into a texture. So we're trying to give you as much time as possible with your buffers to do what you need to do. For Gear VR, they block on submission. So in the Gear VR API, they block when you submit the frame because they're trying to control and make sure that you're getting a smooth frame rate, to make sure that you're drawing smoothly and that you're submitting, and then you're able to start your next frame as soon as you're woken up to start as soon as that's ready. And Valve blocks on input acquisition. So their motto, their theory is basically that when you get input from the user is when you should start doing things. So they will block the frame on input acquisition. So that means when Nick is writing his Unreal plugins he has to structure his frame in a completely different way for all three of our platforms, which is crazy making for him, and he does not like to do that. So we sympathize with this completely. And it's not just Nick, it means anyone who's taking our APIs and trying to write an application that runs on more than one of our platforms has to fundamentally structure their frame completely differently in order to support multiple platforms. So I'll give Nick a chance to talk about this.
Yeah, I pity any small group that has to ship on multiple applications because of that. This was my kind of pet issue that I would love to see solved and rectified across all of them. And I don't even mind how the chips land on it. I just want to be able to optimize our pipeline because it's a pretty complex pipeline to take into account one solution as opposed to all the solutions. Because right now we suffer a little bit on all of them in order to make the compromises, and then we have to do all this crazy swapping of the ordering of how we do things depending on which headset you're running on, and that leads to code maintainability nightmares. And it just means that we are more performant on some systems than others, even though it's not a huge difference. The problem of the performance cliff, where if you go slightly under 90 frames a second, you drop down to 45 and have to rely on reprojection, means that it's sometimes enough to push us over the edge. So both from support load and my own engineering sanity, I am very much looking forward to this becoming standardized.
Okay, we've reached the end of our technical panels. We have some lightning talk questions if you don't have questions, but if anyone has questions, there's a microphone right there, and we will gladly take them.
With all the AR devices coming out, like Tango, HoloLens, all that stuff, have you guys thought about adding like API support for that? Because it also kind of goes back to your car analogy, where it's almost like it's kind of early, but it'd almost be better to prevent the fragmentation now. So have you guys talked about anything more in the AR world?
I can take
Sure, I
it.
can take it too.
Yeah, that's kind of intentionally why we called it OpenXR as opposed to OpenVR, AR, or MR. Especially MR, we kind of have a lot of joking around in the working group that MR means everything to everybody, right? With the AR, I think there's a lot of commonality. Fundamentally, you're relying on getting a pose and timing some render data, and whether that render data is coming from pose acquisition or it's coming from a camera pass-through, we've seen AR devices that kind of support both. Besides, so we would like it all to fit under one standard in there. I don't think we're ready to standardize some of the other stuff that happens with AR, but it's a good shot. You know, it's good that if we can make VR and AR a little bit more compatible in terms of what interfaces you're using, I think that's a win for everybody because that will ease the transition for people that are currently developing in VR to AR platforms.
Yeah, I completely agree. We have the Tango team at Google. They are amazing. We've been trying to engage them and get them involved as well, and take input from them because they've learned a lot over the times that they've been working on Tango and trying to leverage the knowledge that they have to make OpenXR better.
Hi. The Oculus SDK has some pretty handy entry points for in-world quads in their compositor. Any plans to integrate that kind of thing into the API?
You mean the quad enrolled layers?
Sure. So you're talking about like a quad layer, which has just got your UI and overlay stuff in it and stuff like that?
Right. So you can do big resolution, small, and it all gets...
Without getting into the details, I think that there are a series of compositor layers that are defined. I kind of skipped over them because I was trying to get through that slide for time purposes. But there's your typical eye buffer, which is warped, and then a quad, which is just whatever you put in a quad. Then there's also equirectangular video and cylindrical. These are all kinds of layers that we've talked about how they have to be supported.
Projection.
And then projection, straight up projection. And so then there's a little bit of a back and forth about, so yes, all those layers are under discussion. I imagine that they'll all be supported. There's a question as to where you draw the line between core and extension, and what kinds of layers, and what those parameters are, and that's just all part of the process of defining the standard.
Kind of goes back to that concept of extensibility. That was one of the first ones that we ran into, where we decided that we needed to make it something that was extensible, because Oculus at the time was implementing support for cylindrical layers and all the other kinds that they support, but they're kind of ahead of the pack versus the other people there. So is it something that we put in the core SDK? Is that something that we can support via extensions, since it's a relatively simple concept? My personal opinion when we were having that discussion was it was a good thing to throw in extensions, because while we have a set now, who knows what that's going to look like in a little bit, especially when we start getting some more optically interesting devices coming down the road. I think we'll need to do some fancy things with layers.
I'm curious to know how we sorted out the coordinate system when we have varying fields of view. Like, how does a coordinate system work? Where's 0, 0?
That was actually what we were debating on last week's call, so very topical question.
Yeah.
It's also on our lightning talk questions.
What's that?
It's also on our lightning talk questions, so.
It is.
So happy to, yeah.
Well,
So it's quite complicated. If you look at the Tango SDK, for example, they expose quite a few coordinate systems, and they need them all. So we require different systems, different coordinate systems. A system that uses inside-out tracking, which we're coming up with HoloLens, uses inside-out tracking. The things that we announced are also using inside-out tracking. So as that's coming online, it requires very different coordinate systems too, in some ways, because if I start and I say start space is the coordinate system, the reference coordinate system, is it okay that 0, 0, 0 moves when the sensors drift? Is that okay? And I don't know if that's okay, so we need to talk about that. And then, is it okay when Tango does something called loop closing? So in Tango, if I point my camera that way and I turn around in a circle, there's drift happening. But when I point back to there, Tango recognizes, hey, I saw that before, now I know where I am and I know what the drift is. Tango will do what's called a loop closure and adjust the coordinate system to be. So what does that look like? Does that look like a movement? Is it okay if I move in the coordinate system when Tango recognizes that a loop closure has happened? These are really difficult questions, and it's definitely why we're talking about it and why we're still going to have to talk about it to figure out what we're doing and what's acceptable behavior from the runtime. So, really good question.
Hi. With my understanding, it's not only for performance, but for driving the temperatures down or get better life, especially on mobile. It's best to use every compute unit that is available on the device. Does OpenXR support multi-threading, heterogeneous computing, and sharing buffers between Vulkan Compute, OpenCL, such stuff?
I guess since I said GPU a lot, I should try and answer that. I think the answer is the multi-threading is supported. I'll just go out and say that.
Yeah, sure. Answer is yes.
So the answer is yes. And Vulkan and OpenGL, what is the official status of? Do we have an official status for including those two, like compatibly with those two?
We don't have an official stance on that. But I think since they all fall under our glorious banner of our Khronos overlords, it's probably a safe bet.
And as far as heterogeneous, I think that there's a certain amount of leeway that's going to be given to runtimes for where that work goes. And then of course those other APIs, OpenCL and the compute shaders and stuff, those will be available to applications as they normally are.
Yeah, I think the most important thing that we try to specify is exactly what we expect from multi-threaded applications and what's thread safe, who owns fences and stuff like that.
Yeah, there's a lot of consideration being given to that.
Yeah, so that's how we try to ensure that it's both forward compatible and kind of compatible with best practices currently. We have one more minute.
Yeah, actually, it's multi-thread to begin with, right? Because it's synchronous to the display, so it handles that independently of the application itself, as far as being on different threads or different,
So I'll try and take one more question before we get booted, but just want to quickly put up the party slide. So if anyone is interested in the Khronos party, 5:45, the BOF Blitz after party, so there's the information on it. So Let's go back and take another audience question until we get kicked out, probably by the AV staff.
Hi, on the upper end of the sort of performance, the sort of like the location-based stuff, or maybe the higher-end enterprise, what level are you aiming for supporting multiple users running multiple devices all at the same time? Are you planning on they've got to sort out a machine per user which synchronizes themselves, or can we have one runtime on one machine that will accept 15 users and spread it across 4 quadros or something all in the same unit?
Do you want me to take that one? Right now, we try to avoid specifying things like that. We like to leave that as an implementation detail to the runtime. So if they choose to, under the hood, support talking to multiple devices at the plugin layer, they can do that, and the application can choose to try to create multiple sessions if they'd like. But we intentionally don't specify that and leave it open to both in the specification language.
Thank you.
Okay, so I think we can, maybe panelists, do you have time to stick around after in the hallway if people have more questions? Okay, great. So if you have more questions, you can find the panelists out in the hallway after. Otherwise, I'd like to thank everyone for coming to the OpenXR BOF, and please enjoy the rest of your SIGGRAPH, and hope to see you at the BOF Blitz after party.